Okay, everybody, here's the long-awaited for scintillating video of how to go ahead and draft your maps from your field note data. So what you're going to need for this is one of your triangles. Okay, it could be either one of the two that you've gotten. You'll need this, what they call the land measure compass. Okay, and it's just a see-through grid that's based on bearings. You'll need your little circle template. Okay. You'll need your engineer's scale and a pencil and a handy eraser. Also, what is required to do this exercise is a little zoom's not working, is it? I guess I was zoomed all the way out. Is you're going to need to go into room 3322. Now, I'll just pass it out to you in lecture on Tuesday. So you can kind of just watch right now, and then when you get into class on Tuesday, that's what we're going to be doing. It's actually drafting these things. But you'll need a sheet of graph paper, and this is 11.5 by 17 sheet. The other sheet that you'll need, that's going to be where you put your rough draft. And that's what you use for calculating your error of closure, or another term for that is the precision. And then when you get that done the way you like it, then you just transfer everything onto another 11 by 17 sheet of paper, and that's where your final draft is going to be. I have posted on the window of my office an example of a final draft, and so it's got all the elements of what I'm looking for in the final draft. So there's a number of things that you're going to be required to use, and kind of just like when you're writing your field notes, there's some conventions that you're going to need on your draft map, some things that you will include on it, information, and then there'll be information that you need on your final draft. So anyway. Let's get started. The first thing I wanted to show you was just an example of some really good field notes. Okay, this happened to be from Forrest and Zach had done this one. So again, you've got across the top, you've got a really good, very clear title. You've got your page number on there. You've got all your headings. I normally would put like the bearing, the units down in the next line, but that's okay. I mean, it works. So, but just as long as that the units for each of the columns are in there, skipping a space between the stations, okay, just like we talked about. And then this is a closed traverse, so it goes back to 1. And then the summation of your horizontal distances, okay, so your total horizontal distance would go there. And so they just haven't calculated it yet. They'll need to before they calculate the precision, because that's one of the things that you use. On the other side, they've got the crew members, the date, the weather, the equipment that was used, okay, in detail. The location, looks like they missed writing down HCC campus, but that's okay. I mean, they could fill that in. And then a really nice looking sketch. I mean, it's really well drawn, nice and neat. Not a bunch of erasure marks, which is we don't want to see that. They put in the disc golf areas there. They've got the trail coming down, Friedlander Road, the pond, and then where stations 1 through 4 are located on there. Okay, so very good, very, very well done. Of course, this was not drawn to scale, so you need to put a note reminding folks of that, and then you need to have a signature on there. Okay, so all the elements are there. One thing I did notice is there is one little eraser mark here and one there. So you want I let that slide this time, but you want to make sure that you don't do that in future maps. So, future field notes. So basically, I'm going to take some of these field notes, and I'm going to punch them into a computer website where it will actually calculate the precision, or again, the term for it is the error of closure for you. And that allows you to see what field error you have in your data. So I'm going to pull that website up. Take me just a second to get the PC on there. Okay, very good. So now I got to use the PC keyboard. Let me switch my monitor over so I can see what's going on. Okay, so I'm going to back out here just one page. All right, so what I've got here is a website, and this link is on the Moodle website. So you want to copy that link. It brings you to a place called Underhill Geomatics. There's a lot of folks out there who have things like this. It's so very convenient, and it's really easy to type in the data, and it gives you the results really fast. Very easy to interpret results as well. So this is basically what it is an online map check and area calculator. And so this box here is where you type in your data. So I'm just highlighting the whole thing. I'm going to delete what's in there. And I'm going to type in the field notes that Chase and Andrew and Josh and Jordan had taken, because they actually ended up with surprisingly good closure on there. So it was pretty cool. A lot of folks didn't get nearly as good a closure, which is to be, that happens, you know. It's just the luck of the draw. The first time you're doing this, you make mistakes. So why this is important is you plot how good the data, you plot your data, see how good it looks, see if it meets the criteria that you want in terms of the precision. And when it does, then you can go ahead and create your final draft. If it doesn't, then you go back out and you try to determine which lines you've got the mistakes in. So we're not going to do that with this map, but we definitely will when we do the map that we're going to start on on the next lab period. So you're going to be doing about a 10-station traverse around the pond. And we're going to try to shoot for a closure of like 1 foot of error. We'll shoot for 1 foot of error for every 200 feet, and I'll be thrilled if people get 1 foot of error for every 150 feet. I'll kind of explain what that means in just a minute. So anyway, so the data that I've got is, you don't have to type in units, which is really nice because it's already set to feet, and it's already set to bearings. So you just type it in. I'm going to go south 36 west was their first line. Hit the space bar, 112.3 feet. Then I hit enter. Okay, so easy that is. North 62 west, 153.5. Enter. North 32 east, 137.8. South 52 east, and 167.0. Okay. Hit calculate, and there you go. Okay, so there's the bearings and distances. Here's the map, so you can see where it didn't close. I'm going to zoom in on that a little bit more so you can see that better. You see this, it kind of crosses over itself. Okay, sometimes there'll be a gap there, sometimes it crosses over itself. It all depends on how the error is in there, but this is showing you the error in it. Okay, so basically we started here at 1, all right, and we went south 36 degrees west, then we went north 62 degrees east, north 32 degrees west, and then south 52 degrees east, back to 1 again. All right, so the error that we're seeing in here is a result of all the error that's in every single one of these lines. Remember, you've got 2 ways that you can have error in. From your direction, you can have compass errors, or you can have distance errors from using the tape. So it's usually a combination of both, but the error that's in this line gets pushed to the end of that line. Okay, that error is combined with this error, and actually, so basically what's happening is for each consecutive line, the error gets pushed further and further out. okay? And so the error basically ends up over here at this point, okay? We usually call that 1 prime. We just use a little prime symbol with it, you know, like a single quote next to it. So we would write 1 and 1 prime there. So the distance between 1 and 1 prime is the amount of error that I have in it. And they calculate that for you right here. So you've got about 5 feet of error, okay? That's about 5 feet from 1 to 1 prime, okay? Some folks are going to have huge gaps because they may have typed in north 32 degrees west. They may have read their compass wrong, so that's going to throw you off by like 60 degrees. And so, you know, it's those sorts of things that lead up to major error closures. So basically, it calculates this thing called precision. And you see it's kind of like a colon there, right? How that calculated is they add up the total distance, and then they divide it by the error, okay? So this turns out to be so if you took all that and divided it by that, you'd have around 100, okay? So basically what it's saying is for every 100 feet that they've moved along these lines here, they got about 1 foot of error, okay? Which is not great, but it's not bad. I mean, it's all right. It's probably more like pacing. I think pacing, people who do it really well get like 1 foot of error for every 80 feet, something like that. But so, you know, if I was using a steel tape and using all the proper surveying techniques, I can get that to 1 to 200, 1 to 500. If I was using much more accurate angle measuring devices like theodolites, and then if I start using electronic distance measuring devices, lasers and stuff like that, I can get this thing to 1 to 5,000, 1 to 10,000. That's 1 foot of error for every mile, or 1 foot of error for almost every 2 miles. So that's what surveyors shoot for, okay, those sorts of precisions. We're just in the world of a 1 degree you know, hand compass and a nylon tape, which we may or may not be holding very level. So see why we end up with these sorts of precisions. But the more carefully you measure your data, the higher your precision is going to be. So the point is, at some level, you just say, this is not good enough. I have to go back out and collect some more data until I reach whatever that threshold is that you're trying to use for that particular job. So, like I said, this next job we're going to be doing, we're going to be shooting for like probably 1 to or something like that. And but if you get 1 to 150, I'd be very happy. All right. So before the advent of computers and having them allow calculate all this stuff. Oh, the other thing is it gives you the area. Okay, that's square feet. So I would just divide that by 43,560, and it gives me acres. It looks like it's about maybe a 1/4 acre, maybe a 1/2 acre, close to a 1/2 acre. So the next thing that we're going to do is we're going to plot this data onto a map, on a paper map. And by doing so, you're going to be really following the old-timey way of doing this stuff. Let me pull up the document camera again. Let me change it's already nice. So I'm going to use that same data set because the closure was pretty good on it, all right? Pull my chair over, myself situated, and let the wild rumpus begin here. All right, so looking at my map, the one that we got from the computer, basically you could see that it always draws the map with north to the top. Okay, so you could see that this is pretty long from north to south, but actually it's longer east to west. All right, so I'm going to orient this map on my 11 by 17 sheet of paper, I'm going to orient it landscape. I'm going to have the paper long east to west and short north to south. Okay, so when I do that, I start off by, and I'm going to zoom out a little bit. Here's the edge of my map. So basically, I have to decide which way is going to be north. So I said I was going to do the long east to west. So I'm just going to orient the map so that north is on one of the long sides. All right. The next thing I need to do is to figure out what scale I want to draw this map to. And again, you know, I keep saying drawing this map. Really, what I'm doing is I'm just plotting the four corners. This is not my final draft. This is just a rough draft so I can calculate my area of closure. All right, so I know I've got the longest line on this one is this one right here. It's 167 feet. Let's just say it's 200 feet. Okay, I just kind of round up to the nearest 100 foot. And then I can find that on my scale here. So what I would be doing is seeing if I'm looking on my scale and going, oh, well, there's 200 right there. 167 would be right about there. So if I use the 20 scale, I could probably go from here to here. That would probably work, except for the fact that it may be a little too long because the bottom of my page is right here, just below this finger. So the problem I'm having with that is I may, on my next line, fall right off the edge of the earth there, right? So I probably want a smaller scale. And so the 30 scale might work, right? So there's 200 on the 30 scale, where 20 is. So if I did 167, that would be right about here. There's 160, 165, and then two more over makes 167. So if I did that, you know, that just might work. So I think I'm going to stick with my 30 scale on this one. So I know that this point, which happens to be point number 4, is the northernmost point on this map. So I'm gonna plop 4 up here somewhere. And I made this sheet of paper so that the grid on it is really very grayed out. That way you can see your pencil marks on there nice and easily. So I'm going to zoom in. Now notice I'm going like almost right up to the top of my map because I know this is the northernmost point. And so by putting a little dot right there, and notice I'm not sure if you could see where I'm putting it, but I'm putting it right actually at one of the crosses. Okay, I'm not drawing it in the middle of the squares. I'm drawing it actually right where the squares cross. So zoom in a little bit further so you can kind of see what I did. Okay, so I just got a little tiny dot, and I was saying in class, and I can erase here. Okay, no problem. Erase it on your draft map. And my eyes are not all that clear. And all right, so I put a little dot on that map about the size of a piece of bug poop. Okay, teeny tiny little dot. And I'm just going to label it. I know this is station number 4. Okay, so that's where I'm going to call 4, and so basically going from 4 to 1. This is 1 to 2, 2 to 3, 3 to 4, and 4 back to 1. Okay, so I'm going to draw this bearing first. Okay, you could start wherever you want on here. I just wanted to find which corner was on the northernmost point, so I can make that my starting point with my data. So I need to go south 52 degrees east, 167 feet to get to station 1. Right? How do I do that? I'm glad you asked. Here's my compass, and let me zoom this down here a little bit closer. But not too far. I'm getting used to trying to figure this document camera out. Now notice what I've done. I've put the little piece, I've centered the circle right in the middle of the compass on that little piece of squashed bug poop, okay? And I'm lining this black line up with the east-west lines, and then I'm lining these red lines and this black line there with the north-south lines. So they give you lots and lots of lines to line things up with. And that's not perfect, but I have to kind of stand right over it and see if it looks pretty good. And I'm going to go south 50 degrees east. So there's south 50. Well, you can't see it. Here we go. Let me get it up over here. So trust me, I've got it lined up. Okay. So I go south, and I take this. There's 50, 51, 52. You'll notice that this compass actually goes to a half a degree. So if you had an instrument that was reading to 30 minutes, you could actually plot that out with this, but we're not. We're just going to the nearest whole minute. So once I get that in there and lined up, I double check, make sure all my lines are lined up, okay, east and west, north and south, and then I just put a little dot like that, okay? So there's that is the, I'm going to zoom out a little bit now. So that is the direction that I'm trying to go, all right? That's not the distance yet, that's just the direction. So the distance I need to do, again, I'm going to use the 30 scale. So basically, I want to write my scale down somewhere so I don't forget. So that's a piece of information that you definitely want on your draft. So I'm just going to write it in here. 1 inch equals 30 feet on this map. All right, so very important, so people know what scale you've measured this to. So now I'm going to go and find 167 feet, and I'm going to line it up with those two marks. Okay, so how easy that is. So I got the 0 lined up on the little squashed bug poop. I keep saying that, but so now I'm going down to 167. All right, and slide this whole thing over again. To see. So I've got it up on the 0. The 0 end is up on number 4, and I find 165, 166, 167. Oops, well, a little too crazy on that. Let me line that up again. Right there. Okay. So I can double check it, which is what I'd probably be doing, as I'm going along with this, just to make sure that I've got it right. Oh, it looks like it's not quite right. I'm making sure I'm lined up on that mark there, which is my directional mark. So 165, 66, 67. So I should have been a little bit further down. I'm going to erase this and do it again. Okay. 167. Right there. All right. So go a little dot, circle it, call it 1. Next one, I'm going to be going now from 1. So I've just done this line. Now I'm going to go from 1 to 2. Did that line there. I'm going to do this one, which is south 36 degrees east, 112 feet, I mean. So again, I line my compass up, north and south, as carefully as I can, and then I turn this to 136. Check, double check. Make sure things look lined up really nicely, both east and west and north and south. And then I put a little dot right there, okay? Hard to see. Do not draw great big globby dots. globby dots don't work, okay? You want very small, almost imperceptible little dots. So again, I'm checking, make sure I'm using a 30 scale. And this time I'm going to be going, how far? 112.3 feet. Can I find 0.3 feet on this? Probably not. I'll probably just go to the nearest whole foot. But I'll give it a try. So here's 100, 110, 111, 112, okay? So I could either hold the 0 end up here and find 112 feet down here. I'm going to go the other way. I'm just going to set it at 112. Maybe try to go a little bit further to kind of incorporate that extra 0.3 feet. And then I swing around until I find my little dot. I know you probably can't see it, but that's what I'm trying to do. Try to get that lined up. And I feel pretty good about it. Put a little dot down there, circle it, call it 2. Okay? So now I'm going to go from 2 to 3, and then I've got to go 3 back to 4. And because I started at 4, my plotting, all the error is going to get pushed up onto 4 up here. Okay? So I'm going to end up with a 4 prime. All right? And I'm going to measure that distance between 4 and 4 prime when I'm done. So I've got 4 plots to do, and I'm going to go ahead and stop the video for a second and get those finished up just to save you all a little time. All right, so I went ahead and finished plotting this. And let me zoom it in a little bit for you. What happens here is there's my beginning point, 4. I've labeled it 4. And then all the error of plotting it, I've got 4 prime. See that little mark there? I'm just calling that 4 prime. So I'm going to measure the distance. Now notice that this one's, you're seeing a gap between it, right? Whereas this one, it actually crossed over. Well, that's because I started at 4 here. There's still about the same amount of error. We'll measure it in just a minute. But so you can see, depending on where you start and stop on this thing, it's not gonna overlap here. I wouldn't have expected it to overlap up here, but I would hope that the distance is going to be pretty close to about 4 or 5 feet. Right? That means I did my drafting correctly. Right? Because now what I have in here is not only field error, but drafting error. And that's why I wanted you to calculate what the error of closure was originally, and then see if you're drafting it to the same level of precision that the computer was able to draw it. Hopefully you're going to end up with a similar error of closure. Okay, so that's really the purpose of this exercise. So I'm going to zoom in a little bit so you can kind of see the error and measure that distance. And look at that, lo and behold, it's right about 5 feet. Okay. So 1, 2, 3, 4, 5, using my 30 scale. So what I'm going to do is I call that error, the distance between 4 and 4 prime, that's actually what we call the linear error. Okay? So the linear error in this case is 5 feet. Now I have to add up the total horizontal distance for this particular map. I'm going to do that here. I don't have my calculator handy, so I'll just resort to old-fashioned ways. So we got 8 and 8, that's 16. There's 3, 6, 13, 20. So 2, 3, 8, 11, 17, and then 1, 2, 3, 4. So 570 feet. So you can see 570 feet divided So the total distance, total HD, is 578. All right. So the error of closure, or the precision, I'm just going to call it EOC. Okay, and that's what we're going to be calling it in this class. But like I said, you'll see it actually called precision. All right. The error of closure in this case is 578 divided by 5. And that's going to end up being what, about 110, something like that. Somewhere around 110. Use your calculator, okay? I'm not going to use one, but it'll probably be about 110. All right, somewhere in that range. So what that's saying is I've got 1 foot of error in every 110 feet horizontal distance. So basically it's 1 to 110, all right, is my EOC. All right? So that's what you're shooting for with this. So this draft map needs to have a number of elements on it. It has to have a north arrow so people know where they're, how they're orienting the map. And you need to have a starting point and an ending point. So if you start with 1, fine. If you start with 4, I always like to pick an edge. And so in this case, again, I picked the northernmost edge. You could have started down there, you could have started here or there, okay? I could have put 1 way over on this edge of the sheet and put it somewhere in the middle, okay? It's up to you, you know? The thing is that you're trying to create a map that's large enough that it fills this paper up fairly nicely. In other words, I don't want to have a teeny tiny little polygon, you know, so I determined the scale that's going to fit that map nicely. Okay, in this case we used 1 to 30, 1 foot equals 30 feet, 1 inch equals 30 feet, and then using the compass and the scale, I plot out all my points. So start at 4, went from 4 to 1, 1 to 2, 2 to 3, and then 3 back to 4 prime. And from 4 and 4 prime, I'm able to calculate my linear error. Oops. Okay, which is just the measurement using the same scale. Total horizontal distance, I use that for my field notes. I divide my total horizontal distance by my linear error, and that gives me the error of closure. Then I just write the error of closure here as a fraction, which is interpreted 1 foot of error for every 110 feet of horizontal distance around my map. Okay? So that's what you're looking for. You're looking for that number to be within your acceptable limits. And if it is, then essentially you kind of forget about 4 prime. Because 4 prime is really, it's an abstract point anyway. That's really 4 right there. So if I get an error of closure that says, you know, say 1 to 150 or something like that, then I just kind of forget that 4 prime exists. 4 prime does not end up on your final draft, okay? Let me repeat. 4 prime does not end up on your final draft, all right? So you, once you calculate it, and for your draft map, you just simply forget about it, okay? A couple of other things. You probably want to have a title on this. Survey number 1, red, and you probably want to have a date. 1/26/18. You definitely want to have your name on it. And let me think of what else you might want in here. You've got your scale. You've got all your other data in there. You have your arrow. Looks pretty good. All right, so not bad. Now, so the rough draft is just simply to see how well you surveyed it, okay? And if you really mess up, if you have a huge gap here, it could be that you drafted it incorrectly. So double check the way you drafted it. Make sure that you measured those little marks, your angles correctly. Okay, so there's a mark there, Make sure there's a mark there, get another mark over here somewhere, okay? So try it again. You just go ahead and lay the scale back down, lay the compass back down, and just double check your data. If you do finally get it plotted to the point where you're convinced that you've plotted it nicely, but you still are not meeting your error of closure, then you need to start going out to the field and figuring out where your error is. Notice that this gap is kind of oriented this direction. Imagine if I took this angle and swung it just a couple of degrees that way. This whole side would move and that gap would close. So this is a likely suspect, okay, this angle here. So I might want to go back and remeasure that bearing. Again, if I took this angle and swung it this way a little bit, this whole side of the polygon would also swing up a little bit. So this angle right here around 1 and this angle around 2 are suspect for being angular error for that. All right, so that's the kind of game you start playing, and we'll be doing that. You're not going to create your final draft of your pond map until you get the error of closure to meet some minimum level, like 150 or 200, somewhere in that range. So the next step, once you reach that point, now you're ready to do your final draft. And the final draft is pretty cool. I'm going to do a really kind of a hack job on it. I don't want to see you do a hack job on yours. But essentially what I'm going to do is I'm going to get my nice clean sheet of paper, and we have a light table in the GIS lab. We also have windows, and that's what I'm going to do here. I'm going to use the window. All right, and so you can't see what I'm going to be doing right yet, but basically I'm going to, I usually tape this map to the window, all right, and then I just use the window as a light table. I put this map over it, maybe just tape it slightly to the window, and then I can see the dot, okay? And so give me just a second. I'm going to put this on hold, and then I'll come back and show you the results, what I'm talking about. All right, back again. Didn't take long. It took just a couple of seconds, really. Now, I know you can't see them, but there's a dot here. There's a dot here, a dot here, and a dot there. Now, on the original map, 4 was way up at the top of the sheet. So what I did was when I taped the first sheet to the window, I took this second sheet. It's really hard to do with the zoom levels that we have on this document, but I took the second sheet and I laid it on top of it in such a way that all those 4 dots were going to be centered inside my final draft sheet, okay? So again, I got a dot there, dot here, and dot there. It's not perfectly centered, but this is where you try to get balance into your map. You don't want your property to be scrunched off in one side or the other of your final draft. So basically, you line everything up real nice and neat. Make sure that when you're doing it, that the sheet is aligned nicely with the grids, so that it's not crooked. Okay, you don't want to have anything like that. So you get it lined up nicely, you center it, and then you just very, very lightly put your little 4 dots on it, okay? Once I get that done, I no longer need my draft map at the table. So the next thing I'm going to do is draw my little circles around it, and this is where your circle template comes in handy. I like to use the you can use any one you want, but I tend to use the 1364 right here, this one, okay? It makes a nice size circle. You can do a 1/4 inch if you want, but don't use these big massive ones. It just looks stupid, right? So don't make your map look stupid. What I line Let me zoom this in. This might require a little zoom in action here. So here's my 1364, there's my little dot. And what I'm doing is I'm just trying to line up these crosshairs, hit that and that and that and that with my with the dot, so the dot's in the center. And I just carefully use a pencil, draw a circle around it, okay? And this is going to be 4. Use as neat a handwriting as possible, okay? I'm going to do the same for 1. That was a little offset, not as good as I like. Do the same for 2. Okay. And then this for 3. Take your time with it. So I could label these, okay? I usually like to label outside the map itself. All right? Now, the next step, I'm going to zoom out a little bit. You can see what I'm doing, is kind of a standard that folks do is they don't draw from dot to dot. You draw from circle to circle. So I'm just going to use my straight edge. Now notice I'm lining up the 2 dots, right? I have them lined up perfectly. And then I just connect the circles. Okay? All right. Simple as... Now notice I'm not using my scale to draw the line. We don't ever use our pencils on the scale there except to make the tiniest little marks. And then this one. Line up the dots, connect the circles. Okay, take your time with it. Nice and neat. Perfecto! All right. Now the next step is to neatly do your lettering. So I pick a spot that's halfway through. I draw a little guideline. Draw another little guideline below it. And I write my lettering. I need my field notes again. Where's the field notes? There they are. So this is going to be from 4 to 1 is south, a little more lead, south, 52 degrees east, 167 feet. Okay? Easy as can be. You can erase some of those guidelines, clean it up a little bit. That's why you get that nice big fancy eraser and eraser guard, but it doesn't matter to me if you leave a little hint of a line on there. So you do that for all of them, okay? And what I do is I never write upside down. I always read it so that it's going left to right. So in this case, I'm going to go ahead and do this one. Go ahead and mark these. I'm going to write this one with all my bearings on the outside and all my distances on the inside. Okay, so left to right for this one means I write it this way. So from 3 to 4, it is north 32 degrees east. I want to see much better handwriting than mine. And it's 137.8 feet. Okay, bearings on the outside, distance on the inside. reading from left to right. This one, left to right, is this way. Okay, so that's from 2 to 3. It is north 62 degrees, west. Oops, did I mess up? I messed up. If you do that, okay, no big deal. I'll let it slide. I was going to keep my bearings on the outside. So 153, 5 feet. And then this one, to the right, is going to be going this way, okay? So from 1 to 2, it's south. I'm just going to continue doing what I did before, so I'll just write this one on the inside now. South, 36 degrees, west, and then I went 1, 12, and 3 feet. Okay. So you got your bearings, your distances, all written out nice and neat. Then the next is to do your lettering. Okay. And of course you would call this survey. Number 1. Red. You're gonna have a north arrow. Now, guess what I like to give y'all? I like to give you all, and make sure that north arrow is actually pointing north. We know north is on the top of the is pointing to the top of the sheet. So what I'm doing is I'm lining this up with the bottom of the sheet, so it's this line is going due east and west, and then I figure out where I want to put my north arrow, and I put it in. So now that north arrow is facing north. If I see a north arrow that's crooked, man, I'm going to get you. All right, so that's the minimum I'm looking for a north arrow. But I do have, I'm sorry, I can't even see it. Minimum, I'm looking for a north arrow. But if you're talented and you want to make take a chance at the North Arrow Challenge, we have a contest every year, and I give extra credit to the 3 best, okay, that come out. So you've got that in there, and then you also, of course, you want to have your name on it. So the date, and you need to have the scale, so you want to write that in here somewhere. And again, if you need to, draw little guidelines, okay, for your lettering. Scale, 1 inch equals 30 feet. Okay. Neat as you can get it. Arrow, scale. Then you also want your accuracy estimates too. So you're going to write over here. You're going to have, you can put it in a little box on this side. You can call it data block. That's fine. Or you could just, as long as it's in here and it's written neatly and it's balanced, you get some nice balance on the map. I'm just going to click right here, and I'm going to say all that information I had on my other map. Linear error. Five feet. Total HD. What was that? 570.6 feet. And then the EOC was 1 to 110. Okay. I think that's about it. those are all the elements of a good map. You gotta have a title, you gotta have a north arrow, definitely have to have a scale. You don't have a scale, you sunk, man. You gotta be able to provide, folks with who drew it, when it was drawn, and then some good clear information about what is the relationship between Station 1 and Station 2. Now later on, when we go ahead and calculate acreage, you'll probably just write in the middle here, something like 0.51 acres or something like that. We haven't calculated the acres yet, but that's probably where you'll put that. And also, you could start drawing in, to a certain extent, some other features that are out there. Okay, and we're going to do that when we do the pond. That's going to become more prevalent when we do the pond. You'll see that there'll be an island that you could measure. There's the trail, and you actually could measure from these points to landmarks out there, and that allows you to actually plot them with a certain amount of accuracy. So those are what we call offsets. So we'll be doing some of that with the next map series that we do. All right, well, that pretty much finishes this up. Get ready. When you come to class tomorrow, on Tuesday, sorry, I will provide you the paper. You absolutely have to bring your drafting kits. Everything that's in your drafting kits, okay? Your scale, triangles, your little circles, your eraser, your pencil. Don't forget a calculator, because you're going to need that. And you'll need your little compass as well. So don't forget all your gear. You will also need your field notes. Okay, so don't forget to bring your field notes on Tuesday. And that's what we're going to do. We'll have a itty bitty quiz to start things off on Tuesday, and then we're going to finish up with the rest of the lecture portion with you getting started drafting these maps. Okay, so again, this was to kind of get you started with it. And before you come, it would be a great idea that you go out to that website and you go ahead and you plug the data in and you see what your map is supposed to look like if you drew it correctly. Okay, and again, for some of you, it's going to look really goofy. All right, but that's okay. We're just practicing right now, and we'll get it right on the next time around. Okay. All right. Well, I hope you all have a great rest of the weekend, and we'll talk to you guys on Tuesday. Bye now.